So now here next part is here average kinetic energy per molecule of gas and kinetic interpretation of temperature. So here we will be using formula of the pressure exerted by ideal gas. Now see here, consider 1 gram mole of an ideal gas having volume V and temperature T. Then we can write here m is equal to total mass is equal to m into Na, that is Avogadro's number, where m is the mass of the each molecule of the gas. Now we know the formula P is equal to 1 upon 3 m upon Vc square. We can write PV is equal to 1 upon 3 m into NaC square. Na is Avogadro's number. Now PV is equal to RT, because you know it, that is 1 gram mole already I have considered. So it is here 1 upon 3 mNaC square. Now if you take Na to this side, you will be getting R upon Na into T is equal to 1 upon 3 here. So we can write 3 here, and here we can take 1 upon 2 mc square. So here also we can divide by 2. So R upon Na can be written here 3 by 2 kBT. Kb is a Boltzmann constant, is equal to 1 upon 2 mc square. So we have got this relation here, 1 upon 2 mc square is equal to 3 by 2 kBT. So this is actually known as So 1 upon 2 mc square is equal to 3 by 2 kBT. So this is known as average kinetic energy per molecule of the gas. It means average kinetic energy of one molecule. And from here also, or from the previous relation also, we can write from here only C square is proportional to T. So C is proportional to square root of T. So the root mean square speed is directly proportional to square root of the temperature. So now we have seen C is proportional to square root of T. It means root mean square wave speed is directly proportional to the absolute temperature. So if you are taking, suppose T is equal to 0, when T is equal to 0, so you will be getting C is equal to 0. Thus we can say absolute 0 is that temperature at which the root mean square speed of the gaseous molecules reduces to 0. So we can define absolute 0 by this. And also one of the thing is here, kinetic energy, average kinetic energy per molecule of the gas is directly proportional to absolute temperature, because rest everything is here constants. So this is about here the average kinetic energy per molecule of the gas and kinetic interpretation of temperature.